So the next 20 minutes, we're going to spend some time understanding a bit about the spot instances and how you can use the spot instances on containers workloads. So I'm Carlos Rueda. I'm a specialist solution architect focused on spot instances, and they overlap obviously with quite a few of the services that we have. Before starting with this presentation, please raise your hand, those who are using spot instances at the moment. That's brilliant. So there's a few hands. That's really good. Cool. So let's start first with what I would like to achieve with this presentation and what are the spot instances. I would like to cover 3 topics. The first topic is what are the spot instances and why you should consider them on containers, container workloads. The second is what are the techniques and methods that you should use to adopt the spot instances successfully. And the third one, how to do or how to use those techniques on containers workloads. Spot instances are, well, spare capacity that we have on our data centers. We offer them as a purchasing option. So you got on-demand instances, reserve instances for a commitment of 1 to 3 years on a reserve discount, and finally spot instances, as I say, spare capacity that we have in our data centers. And that means that if at some point you got on-demand users using a set of the on-demand users using one of the spot instance pool, and they dry that instance pool, your spot instances running on that pool will get a notification signal for termination. You got 2 minutes notification to gracefully shut down your application. And in return, what you get is a hefty discount of 70 to 90%. So spot instances, the first lesson learned here is it's very suitable for fault tolerance and flexible workloads. Let's dispel some myths. We stopped using bidding in November 2017. At reInvent, we introduced a new pricing model. Customers cannot outbid you anymore. The new pricing model is based on a long-term supply and demand of specific spot markets. Okay? So again, there's no bidding. I've already spoke about interruptions. Let's move on. Spot instances are used in pretty much all the verticals. So my background is financial services, managing very large clusters and grids for pricing instruments and also for calculating risk. Over there, for grid computing, they are essential to scale. On the research side, on life sciences, genome sequences, you got also machine learning, any kind of solver and data analytics, media and entertainment, rendering and transcoding. And there's a bunch of other consumer apps. Container workloads is one of them, web applications, CI/CD, only the CI part, right? We've been talking about that this morning. And you got customers that are using it as Pinterest, Lyft, Yelp. We're going to mention a specific customer later on that is doing a great job with spot instances and Kubernetes. In terms of where we integrate spot instances, so let's just start with the services at the top. EMR, if you already have Hadoop, Spark, Flink, or PIM workloads working on those, they already provide with the fault tolerance that the application needs to, if at some point you got one instance for whatever the reason terminating, the job will be retried. And you get the same thing for batch services, for AWS batch, and also for Islam and the parallel cluster autoscaler, parallel cluster, and so on and so forth. So that's for compute. On the containers space, we're going to deep dive later on ECS, EKS, and Kubernetes. But you can also use it on methods, no matter whatever procurement system, orchestrator system that you need resources for. Then for CI/CDs, we have integrations with Jenkins, Bamboo, and TeamCity. Even if it's not in there, there's an integration for that as well. So let's move to what qualifies a workload as a spot ready. And you're going to see over there that we've been speaking about this stuff pretty much the whole day, right? About services and microservices as well. For as long as you are stateless, loosely coupled, fault tolerance, and you're keeping at some point a checkpointing somewhere, you are pretty much eligible for spot instances. which make it great for stateless containers workloads. Okay, so that should look quite familiar for those of you using containers already. Cool. So this is one of our customers that is using Spot at the scale. Skyscanner is a travel fair aggregator, so if you're looking for holidays, they will look for 1,000 combinations of flights and selecting the optimum flights for you. It's a quite seasonal business, right? So they need to scale what they need to scale, holidays and so on. And they run pretty much everything on Spot instances, thousands of containers, thousands of nodes as well. It's a brilliant use case. They've been going through a journey from development and test to get the confidence and the observability points, and finally to production. And now they're saving up to 74%. So before we move to the next section, which is the techniques that I mentioned, I would like to do a call for action for you. I'm pretty sure that some of you already have production workloads, test and UAT workloads, and some of you are thinking about what's the next project they're going to be working on. So for those who are thinking about the ideas that they have today, how they're going to implement it, why don't you try with the Spot instances? I'm quite passionate on believing that Spot instances are an innovation enabler. There's a cost on innovation. If you can reduce that cost, it means that you can do more iterations, right? Or you can try more things. And for those of you who already are running your workloads, well, you could try starting with the Spot instances in development and UAT, get your observability, and think, what are you going to do with that 70% of savings? What are you going to build on for your customers? Okay, so next section. Let's move on techniques. I'm going to try to be a quick one with that. We covered a bit on the pricing. This is the day that we switch on the new pricing model. So you see that pricing model is now long-term capacity that is changing in a smooth way, kind of predictable way as well to an extent. You see that the bidding strategies were going even over the on-demand price, so that's not happening anymore. First lesson learned on this one is when you are using Spot these days, you don't need to set up your maximum price. It will pick up the on-demand price, and you will be charged still at the market price. The price will never go on top. It will never go above the on-demand price. Make sense? So the next thing I will highlight, and this is probably the most important part of this presentation, is diversification, the concept of diversification with the Spot. If you want to be successful, you need to be flexible and diversify. So let's cover first for that, what's a pull? I mentioned if you dry out a pull, you will get a notification for termination signal and 2 minutes to shut down your application. So I pick up over here the C4 family. So on that instance family, and on all the sizes that we got over here on the y-axis, and then for all availability zone, on every region, what we got is a separate pool with a different price and a different curve that changes over time with the price, depending on supply and demand of that particular pool. So let's pick the C4 XL on availability zone 1A. It's 4 cents at the moment, right? So if at some point that pool dries, so there's quite a lot of demand users that are using that particular pool, what we would like to do to be successful with the Spot is replace and get some other instances from other pools. And that's where the diversification concept comes along. You will have to pick instances also from the rest of the availability zones to be reliable as well. So 1B and 1C. If your workload, for whatever the reason, is very sensitive to data movement, you could stay on the same availability zone, but instead use the 2XL and the 4XL. Yes, they are larger. They cost more. But you are still saving over the on-demand price. And you are kind of proving yourself and reducing the blast radius when that pool dries. Does that make sense? And you can extend all this with the rest of the instance family. So if you are using a C4, why not using also a C5 and perhaps an M4 and an M5? They're going to offer you a bit more memory, right? But they should be fine as well. Okay, so in this slide, what you got over here at the bottom left is a diversified fleet running. Okay, so that Diversify Fleet makes the point for this argument that I mentioned about reducing the blast radius, making sure that if one of those dies, you still have quite a lot of families that are unaffected. And you are still saving 72%. This is one of the dashboards that we have for capturing snapshots of how much we are saving. Okay, let's move ahead. What about interruptions? So the fact is only 5% of the servers that are spot instances are interrupted by us, by Amazon with the on-demand. 95% of them are actually shut down by the user. How to handle interruptions? There's two ways. One of it is basically setting up a loop over the instance metadata URL, spot instance action, and check out if you get a notification signal. If you get that notification signal, you drain your containers, you remove it from the load balancer, and so on. The second one is using CloudWatch events. So effectively trigger a Lambda and effect exactly the same kind of calls, drain it from system. Okay, so the next thing I'm going to be moving for, so that's another technique. Next technique is we released 10 years ago, last week, auto-scaling groups. For handling the heavy lifting of replacing instances, you don't have to do that yourself. You can use auto-scaling groups of fleets or EC2 spot fleets. They already support all these concepts of adding this diversified technique that I just mentioned. In fact, since November 2018, we can also mix and match on-demand and array pulls on it. There's these launch templates that go on the back of it that I use to effectively handle what are the instances that you are supporting on the back of that. Okay, so lesson learned on that one, or the technique learned on that one is use launch templates and auto-scaling groups. Cool. And finally, the last lesson is how to build up those groups. And for that, you can use a Spot Instance Advisor. So Spot Instance Advisor is an aggregate over the last 30 days, provides an aggregate over the last 30 days on the frequency of termination and the savings that you got for each instance family on every region. You can educate yourself on what will be the best construction for your fleet using a Spot Instance Advisor. Right, so we've seen why we should be using Spot instances on container. We've seen some of the techniques that will make us successful. Now let's move on to where to apply those techniques on container workloads. So the first one is, I'm going to cover quickly ECS. It's quite well integrated. So if you use, you go through effectively through our construction for fleets, for ECS, and select, not Fargate, but Linux or Windows, you'll get into that screen. You see that you have on-demand and spot. For the spot, you will have to choose your Diversify Fleet, and now you understand why that's important. And you also have these lowest and diversified allocation strategies. Allocation strategies is a construct that we have internally for autoscaler and fleet to select what's going to be the next resource that we acquire for you. Diversify means that we're going to diversify it across availability zone and pools of instances. So that's brilliant, optimized for reliable workloads. Lowest, that's what it set us on the team. So the cheapest instance for jobs and high-performance compute in general. It will pick from that single pool that is the cheapest one, even if it's just on one availability zone. You can also bootstrap for using on-demand reserve instances and spot at the same time, using auto-scaling groups as well. And use those auto-scaling groups to scale based on the metrics that you are getting published. Finally, the termination signal can be either provided on the bootstrap for your auto-scaling group. So by default, if you are using our ECS CloudFormation creation for those things, it will be coming directly from us. The CloudFormation template that we use to start your ECS cluster will provide user data to provide that termination signal, that termination handler on top of the ECS nodes. Now let's move to EKS and Kubernetes. Right, and let's start with termination. So you will deploy a pod as a daemon set to the spot instances. That pod is the one that contains the script that looks at the instance metadata URL to check if it receives an instance notification. Typically, you will use a node selector to pick up which are the spot instances and only the spot instances where that pod gets deployed. And when you get the notification, you'll cordon and drain just to make sure that that pod is not used anymore, that node is not used anymore. Okay, so that's one way of handling interruptions. The other way is using labels well, the other way. One of the things that Kubernetes does that is great at is on the orchestration placement, decide where to put stuff. So with your loosely coupled containers, what you can do is use toleration and taint to say this application is fault tolerant. I would like to apply that particular application on spot instances. You can use also affinities and select for those to plug in the right place. And finally, I'm going to end quickly with how to auto-scale all these things. So there's, here the strategies are quite varied. The first strategy is using the cluster autoscaler and then apply these techniques that I just mentioned of diversification on different node groups. So each of those instance families will run with each of those different node groups, and you will still have that diversification that we just mentioned. The other approach is what I got over here on the screen. Some other customers are starting to use AWS auto-scaling groups, pump up those metrics that we've been seeing today into CloudWatch, and decide how to scale those clusters based on those metrics. Finally, in terms of auto-scaling and managing Kubernetes and EKS scaling, we got a quite wide, and you've seen it already, number of partners. For a spot, we got a partner that is called Spotinst that adds quite a lot of value in this space as well. They're going to be at KubeCon. I will quite recommend, if you are interested in spot instances, to come over to our booth, speak to us, but also check what is the value proposition as well. So finally, a few of the takeaways are, as we said, you should consider using a spot on your next project, especially for those fault-tolerant workloads. Then use auto-scaling groups and fleets to do the heavy lifting, the differentiating heavy lifting, or replacing those instances. Make sure that you adopt launch templates. And another thing that has been mentioned today, which still applies, is some instances are more popular than others. We've been talking about GPU instance, P3DNs, and so on. They are quite popular. They're quite in heavy demand. So they're going to have a different frequency of interruption. Understand that frequency of interruption and compose your fleet accordingly. And understand also how to save your state. So for machine learning, dump your weights at different times just to make sure that you can recover and checkpoint. And finally, architect your application. This is not a spot thing, right? This is a kind of well-architected part of our portfolio, right? Architect your applications for fault tolerance. If you architect your applications for fault tolerance, you'll be able to make a benefit out of spot instances. Last of all, you can take a picture of that one. It's 20 minutes that we got for this thing to get into all these concepts. I know that it's quite fast, just running through all of this. We got a workshop, EC2 spot workshop that take you through each of those individual concepts that I mentioned for different type of workloads, container workloads, and so on, right? How to apply them, some examples. Each workshop takes about, I would say, 30 minutes, 45 minutes to an hour to complete. And that's what I wanted to present today. So I hope that is useful for you. Consider, please, for your next project to use spot instances. Thank you.